Low frequency or LF is the ITU designation for radio frequencies in the range of 30 kHz (300 kHz). As its wavelengths range from 1 to 10 km, it is also known as the kilometre band or kilometre wave. LF exhibits low signal attenuation, making it suitable for long-distance communications. In Europe and areas of Northern Africa and Asia, part of the LF spectrum is used for AM broadcasting as the longwave band. In the Western Hemisphere, its main use is for aircraft beacon, navigation, information, and weather systems. A number of time signal broadcasts are also broadcast in this band. Propagation. Because of their long wavelength, low-frequency radio waves can diffract over obstacles like mountain ranges and follow the curvature of the Earth. This mode of propagation, called ground wave, is the main mode in the LF band. The attenuation of signal strength with distance by absorption in the ground is lower than at higher frequencies. Low-frequency ground waves can be received up to 2,000 km from the transmitting antenna. Low-frequency waves can also travel long distances by reflecting from the ionosphere, although this method, called skywave or skip propagation, is not as common as at higher frequencies. Reflection occurs at the ionospheric E layer or F layers. Skywave signals can be detected at distances exceeding 300 km from the transmitting antenna. Uses Standard time signals equals. In Europe and Japan, many low-cost consumer devices have since the late 1980s contained radio clocks with an LF receiver for these signals. Since these frequencies propagate by ground wave only, the precision of time signals is not affected by varying propagation paths between the transmitter, the ionosphere, and the receiver. In the United States, such devices became feasible for the mass market only after the output power of WWVB was increased in 1997 and 1999. Military. Radio signals below 50 kHz are capable of penetrating ocean depths to approximately 200 meters. The longer the wavelength, the deeper. The British, German, Indian, Russian, Swedish, United States and possibly other navies communicate with submarines on these frequencies. In addition, Royal Navy nuclear submarines carrying ballistic missiles are allegedly under standing orders to monitor the BBC radio for transmission on 198 kHz in waters near the UK. It is rumoured that they are to construe a sudden halt in transmission, particularly of the morning news programme Today, as an indicator that the UK is under attack, whereafter their sealed orders take effect. In the US, the Ground Wave Emergency Network or GWEN operated between 150 and 175 kHz, until replaced by satellite communications systems in 1999. GWEN was a land-based military radio communications system which could survive and continue to operate even in the case of a nuclear attack. Experimental and amateur. The 2007 World Radio Communication Conference made this band a worldwide amateur radio allocation. An international 2.1 kHz allocation, the 2200-meter band, is available to amateur radio operators in several countries in Europe, New Zealand, Canada and French overseas dependencies. The world record distance for a two-way contact is over 10,000 km from near Vladivostok to New Zealand. As well as conventional Morse code, many operators use very slow computer-controlled Morse code or specialized digital communications modes. The UK allocated a 2.8 kHz sliver of spectrum from 71.6 kHz to 74.4 kHz beginning in April 1996 to UK amateurs who applied for a notice of variation to use the band on a non-interference basis with a maximum output power of 1 watt ERP. This was withdrawn on June 30, 2003 after a number of extensions in favor of the European harmonized 136 kHz band. Very slow Morse code from G3AQC in the UK was received 3,275 miles away, across the Atlantic Ocean, by W1TAG in the US on 21 to 22 November 2001 on 72.401 kHz. In the United States, there is a special license-free allocation in the long-wave range called LOFA. This experimental allocation between 160 kHz and 190 kHz is sometimes called the lost band. Unlicensed operation by the public of any mode that falls inside the 30 kHz bandwidth is permitted, except where interference would occur to licensed location service stations located along the coasts. Regulations for use include a power output of no more than 1 watt, a combined antenna ground lead length of no more than 15 meters, and a field strength of no more than 4.9 microvolts per meter. Also, emissions outside of the 160 kHz a 190 kHz band must be attenuated by at least 20 decibels below the level of the unmodulated carrier. Many experimenters in this band are amateur radio operators. Meteorological information broadcasts a regular service transmitting RTTY marine meteorological information in SYNOP code on LF is the German Meteorological Service. The DWD operates station DDH-47 on 147.3 kHz using standard ITA2 alphabet with a transmission speed of 50 baud and FSK modulation with 85 Hz shift. Radio navigation signals in parts of the world where there is no long-wave broadcasting service, non-directional beacons or NDBs used for air navigation operate on 190 300 kHz. In Europe, Asia and Africa, the NDB allocation starts on 283.5 kHz. The LORANC radio navigation system operates on 100 kHz. In the past, the Decca Navigator system operated between 70 kHz and 129 kHz. The last Decca chains were closed down in 2000. Differential GPS telemetry transmitters operate between 283.5 and 325 kHz. The commercial data track radio navigation system operates on a number of frequencies, varying by country, between 120 and 148 kHz. Radio broadcasting The long-wave radio broadcasting service operates on frequencies between 148.5 and 283.5 kHz in Europe and parts of Asia. Other applications Some radio frequency identification tags utilize LF. These tags are commonly known as LFIDs or low FIDs. The low-far FID tags are near-field devices. Antennas. Since the ground waves used in this band require vertical polarization, vertical antennas are used for transmission, usually mast radiators either insulated from the ground and fed at the bottom, or occasionally fed through guy wires. T-antennas and inverted L antennas are used when antenna height is an issue. Nearly all LF antennas are electrically short, shorter than 1/4 of the radiated wavelength, so their low radiation resistance makes them inefficient, requiring very low resistance grounds and conductors to avoid dissipating transmitter power. These electrically short antennas need loading coils of high inductance to bring them into resonance. Many antenna types, such as the umbrella antenna and L&T antenna, use capacitive top loading, in the form of a network of horizontal wires attached to the top of the vertical radiator. The capacitance improves the efficiency of the antenna without increasing its height or its supporting structures. The height of antennas differ by usage. For some non-directional beacons the height can be as low as 10 meters, while for more powerful navigation transmitters such as Decca, masts with a height around 100 meters are used. T-antennas have a height between 50 and 200 meters, while mast aerials are usually taller than 150 meters. The height of mast antennas for LORANC is around 190 meters for transmitters with radiated power below 500 kilowatts, and around 400 meters for transmitters greater than 1000 kilowatts. The main type of LORANC antenna is insulated from ground. LF broadcasting stations use mast antennas with heights of more than 150 meters or T-aerials. The mast antennas can be ground-fed insulated masts or upper-fed grounded masts. It is also possible to use cage antennas on grounded masts. For broadcasting stations, directional antennas are often required. They consist of multiple masts, which often have the same height. Some long-wave antennas consist of multiple mast antennas arranged in a circle with or without a mast antenna in the center. Such antennas focus the transmitted power toward ground and give a large zone of fade-free reception. This type of antenna is rarely used, because they are very expensive and require much space and because fading occurs on long wave much more rarely than in the medium wave range. One antenna of this kind was used by transmitter Olander in Sweden. For reception, long wire antennas are used, or more often ferrite loop antennas because of their small size. Amateur radio operators have achieved good LF reception using active antennas with a short whip. LF transmitting antennas for high-power transmitters require large amounts of space, and have been the cause of controversy in Europe and the United States due to concerns about possible health hazards associated with exposure to high-power radio waves. See also, high-frequency, long-wave, LOFA, 2200-meter band, times signal, WGU20, low FID passive or FID tags. References. Further reading, Tomislav Stimac, Definition of Frequency Bands. IK1QFK homepage. Claviter, G. Buchner, M. Herold, K. Langwell and La Currency NGSTWELLE. Meckenheim, C. Bell Verlag GmbH. ISBN 3-89632-043-2. Martin, M. Spezial for Queenslist 2007/08. Meckenheim, C. Bell Verlag GmbH pages 36-39. ISBN 978-3-88180-665-7. Mike Dennison, G3XDV and Jim Moritz, MOBMU. LF Today. Radio Society of Great Britain. ISBN 978-1-905086-36-8.